So I hope you had a good lunch. You're well fed, had your coffee, and there's going to be a pretty interesting afternoon. And at the start, we'll make Marek with pretty pictureful, interesting presentation about rural 5G network. So welcome. Do you want the mic?
Thank you, Simon. Straight at the beginning. Yeah, and play. Go. Fantastic. Thank you for the introduction, Simon. I hope you've had a good lunch, because after a lovely morning of amazing talks where we've been in our offices building, network infrastructure with Git and doing automated testing, I'm afraid it's time to get dirty, messy, cold, wet and muddy, because we're building networks. My name is Marek, though my friends often call me Maz. I founded a small company called FAELIX. We help alternative network providers build and scale their networks. Mostly, we're based in the UK. We have an access provider network of our own there. But we have some presence, and actually, though we've had presence in Switzerland for 5 years, this is only my second time here at SwiNOG. I used to be involved in the programme committee at the UK Network Operators Forum. I'm still involved with a small local NOG in Manchester in the UK. And through these slides, you'll be seeing our mascot, a little cuddly toy moose, because photos of that on social media are way more interesting than photos of, your typical network engineer racking equipment. Je parle un peu français, je parle français comme une vache espagnole, but my German is terrible. These are the languages I can speak. Let me introduce you to where this build is. It's in a quite remote part of Scotland. It's here. It's almost as far north as Stockholm. A little further north and to the east are the islands of Shetland, and then you can see the Faroe Islands further still. There are thousands of kilometres of sea between Orkney and basically, well, the wind blows in this way over thousands of kilometres of sea. And it's lots of small islands, many of which are inhabited, a few only by sheep, but there are tens of thousands of people living here, the majority of which are in the middle, where there's the sort of capital, as it were, Kirkwall. How big is it? Well, on a same scale, here's Basel. Here's Zurich. Or for those of you who know the French side more, there's Lac Léman. We're talking quite a large area, and we're going to be building networks here. How are we going to do that? So for historical reasons, which I'm not going to go into, certain parts of the UK infrastructure are not served well by fibre. And so here was the core of this provider's network. These are radio links. And you can imagine the scale of the length of these radio links based on the overlays I just gave you. But these are radio links over the sea. And the sea has tide, which goes up and goes down, which means potentially you have multiple paths, one that's straight and one that bounces off the water surface, and they interfere with each other. So radio can be a challenge in itself. Also, if you remember, I said there's an awful lot of sea between Orkney and anywhere else. It's quite rainy and quite windy, and those are also not great for radio links. The good news is there is some subsea fibre. So the Faroe Islands own and operate Schiefer 2, which the name comes from Shetland and Faroes, because this fibre goes from Faroes to Shetland, to Orkney, and then to the mainland, and then uses some British Telecom services to get down to London. And you can also see there's some bits coming off to the middle of the sea. There's quite a lot of oil, which this area has connectivity to service as well. But this does mean we get to visit a cable landing station. And of course, there's, it's a nondescript building that looks a little like a house with no windows, with a sign near it that says submarine cable to warn the fishermen not to do their fishing there. which meant we did get to see, here's our mascot again, we did get to see the wet and the dry parts of the fibre meeting. And if you're a submarine fibre operator, you may also have a radar station, as Schiefer do. Reason being, fishermen are really good at turning the transponder off on their boat to go and do some illegal fishing so that the Coast Guard can't find them. They get picked up on radar and the Coast Guard go and give them a visit, and they get a very unwelcome letter as a result. So yeah, when operating some of these networks, you also end up with your own radar station. So why are we building 5G here? Well, the UK government, Cisco, university, came together to try and build what was called a test bed to make a toolkit. And the toolkit was basically a manual of how to build a 5G network to provide fixed wireless access. The idea being this could be used as a template for other alternative providers to fill in the not spots where fibre isn't going to be built by the incumbent operator, British Telecom. A local wireless internet provider, CloudNet, and Faroes Telecom were partnered in this to build this test bed. And there were some challenges we had to overcome early in the project, which are common in an organically grown wireless provider, where you've come along, you've realized over there doesn't have internet, over here does. Let's just fire a radio link between the two. 5 years of that later, you've got this massive layer 2 domain spanning 100 kilometers, and oh my God, everything is terrible. Within this, it was a short-term project, and there were very, very key timescales and reporting criteria. And the ongoing operational responsibility would fall to the local wireless internet provider, in this case, CloudNet. There was also a large vendor involved, Cisco, and they obviously have a preference of what operating system and hardware gets used. And in some cases, in projects like this, they may donate or offer a really good discount for their equipment, and that's great for the capital expenditure, but may not necessarily be the best option for operational costs. And part of the challenge here is this is a remote rural location. There is a small population, and due to the history of energy in the UK, despite the fact there's all this wind blowing to Orkney, and there's huge amounts of wind farms there, the energy there gets exported back to the mainland, and the cost of importing energy back to Orkney historically is based on how far it is from the centre of mass of generation, which obviously is closer to London than it is to where it's actually being generated locally. So there's a huge amount of fuel poverty in these areas as well. Plus, it's a rural area, farming, it's not a very profitable career, usually. So price sensitivity is a key consideration for the customers. So, of course, OpEx, we've got to get it down. So vendor selection. Well, Cisco also offered a core, a 5G core for their network, but due to problems getting that actually turned up in time to actually go live, the whole project ran on Open5GS, which is an open source. You can just download it, install it on some virtual machines, and you now have a fully functional 5G network without the radios. For the radios here, instead of little Raspberry Pis using SDRs, which you can run a 5G network with if you've got licenses and frequency spectrum, blah, blah, blah. But here we used Amarisoft, plugged into basically some PCs, as you'll see, that are acting as the E node B or the G node B. And you can see the antennas and the user equipment, the devices that would be connecting to this. The local provider obviously knows the area very well because they've been operating here, and they know the challenges. And sometimes you have to make difficult decisions around, for example, sparing. While it might be great to be given some beautiful data center ready switches from a large vendor, that might not be the most appropriate equipment, as you will see, to install in some of these locations. So early in the project, we architected their network as a sort of layer 2, layer 3 migration. In yellow here, there's where the 5G sort of build was initially going to be. There are some fibres to actually get connectivity into this network, which we're calling backhaul here. And there were vague plans for like FTTP builds in the future. Where are these two 5G? Well, where's the 5G network going to be built? It's in these two particular areas, which are really poorly served by the incumbent operator. The island at the top, Papua Westray, 1 megabit would be about all you can get from anybody on that island. So we're trying to build something that's going to service far better than that. To do that, here's the radio backbone, and there is some fibre backbone as well. There is a fibre to the island of Westray, into that place called Skelwick. There are radio links, and then down at the bottom you can see the Schiefer fibre back to the mainland. Why were those areas chosen? Well, partly because of poor connectivity, but also because radio propagation would be really, really easy to model and would actually, with a small number of antennas, be able to provide really good coverage. So let's talk about some of the challenges. Here is a typical high site, or a POP, you might think of it as. It's not very high, certainly not compared to the alpine conditions we have here. It's a shipping container, which obviously has a door that's meant to be waterproof and weatherproof, but because of the weather, they actually build a second door inside as well. How windy is it? Well, even though these are locked cabinets for housing the electrical switchgear, you have to strap them shut as well, because the wind will actually rip the locks open. And pictured next to it, that was a wind turbine that couldn't cope with how much wind there was. It's caught fire. Here you can just about see, this is a lovely calm day, and already the comms tower is wobbling. It's an experience climbing one of these, especially on a breezy day. In one of our first meetings, their network engineer, Trevor, warned me that the rain is vertical and it will go upwards. So that drain hole you have in your radio equipment, no. To keep their equipment dry and actually isolated, so if you've got a hole in the side of this cabin, the shipping container to feed fibres and cables through, they actually use these kind of maritime seals, which are used for ship-to-shore cabling. Basically, it's a segmented unit which you feed a fibre through, for example, in one of those black rubberized sections, and then once you've constructed everything, you use the part on the right, slot it in, tighten the bolts, and it expands, squeezing everything absolutely tight shut. And that's waterproof. You'd put that in the side of a boat under the water. It's also not rainwater. Sea salt is really bad. So whenever you make a connection, you wrap it in tape. If it's outside, it's being wrapped in tape. But then you wrap the tape in a cloth tape that's impregnated with this sticky, horrible, waxy grease. Which means if you've plugged something in wrong, everything is now a mess. Your fingers are a mess, your tools are a mess, everything is horrible and disgusting. And that's the process of someone supplied a bad patch fibre from this radio and, yep, needs to change it, and that's the mess that there is now. How quickly do things rust? Well, this is apparently maritime grade stainless steel, and it's been up for 2 weeks and it's already showing signs of rust. What happens if you've got equipment there longer? Well, this cabinet has been there for, I think, 4 or 5 years, and that radio had been up for a couple of years. So corrosion is really quick. The green cabinet behind was to replace, obviously, the piece of rust containing some network switches. So you can see here why a enterprise or data center network switch may not be the most appropriate thing to have in your equipment. And additionally, you're going to have to self-spare, as we will see. Because how long's hardware going to take to get here? And certainly during the pandemic, how long did things take to get anywhere generally? Self-sparing was essential because, as you'll see, getting to some of these places is tricky. Here was a typical day. We'd start at their office, conveniently almost equidistantly far from both the 5G builds. So grab the gear, hop into a car, drive across this rainy, wind-blown landscape, maybe get a boat, maybe get very seasick. Or maybe get a plane, because sometimes that's the only way to actually get between the islands quickly. Side note: this is one of the shortest commercial operated flights is between the two islands of Westray and Papua-Westray. It's a 10-seater plane, and if you go on it, you actually do get a certificate saying, you know, as authenticated by the Guinness Book of World Records. So you get to site eventually, possibly after, you know, your sea legs have reaccustomed to being on stable land, and then you swear because it doesn't quite fit in the rack. So we need to change our plan here because there's not a lot of time. Some of the islands are only serviced by a ferry twice a week. So if you can imagine you're going to need spares on the island, they're going to need to be readily available for somebody local to fix the network. In winter, there are even fewer sailings and there are cancellations because of bad weather. There are flights. They're not common. They're very booked up. It's a 10-seater plane. And again, contingent on weather. So we refined our process a little. We actually built each POP in a box ready to take to site. This is what a typical radio would end up looking like. So this is a 4G or 5G radio where you've got some sort of Supermicro or similar PC server. And this is basically going to be sending the radio signal that we need to emit out of the actual software-defined radio down a bit of fibre. That's what looks like a bunch of SFPs for standard networking are there for, but no, that's actually a specific network card for a CPRI, a CIPRI. Here's a radio, or at least the bit that then generates the radio signals and attaches to the antennas, amplifies the signal. That's going to be mounted on the tower. And here is a fairly typical antenna. They have an awful lot of connections, and it's quite challenging when you're strapped to the tower to make sure you get them all right. We're back to that sticky, horrible, waxy tape again. If you get it wrong, it's not fun undoing it all. So here we are. We've put in an E node B, G node B in the bottom. We've got a network switch, a small router, a little UPS. This is all in something about the size of a refrigerator that actually is a waterproof box. Or maybe it's a more complicated POP site where at the top we've got some CG-NAT functionality, we've got some fibre coming in to actually service that island, for example. And at the bottom we've got the user plane, which transforms GPRS tunneling protocol into IP. And we have the RAN, the E node B, G node B. So while that's happening, while you're racking all of that up, somebody else is climbing up the tower and hoisting radios. They're quite heavy. They're sort of like 15 kilograms plus, these boxes, because they're all heatsink. Possibly there are point-to-point radios that you have to hoist up as well. So in this project, we used Aviat point-to-points on 11 gigahertz licensed spectrum. Now it's time to connect the fibers that go from the SDRs from the actual radios to the part that's driving them, the software from Amarisoft. And thankfully, green lights all round. This is great. And now you've got a 5G network, so check your phone signal. And then realize somebody didn't read the small print. Apple devices will not connect to an unencrypted network. And if you are trying to run a test bed or a non-commercial network in the UK, it has to be unencrypted. Oh shit. The solution to this was a Lightning to Ethernet adapter and plugging it into one of the CPE. But these are CPE made for sending a signal quite far, and we're quite close. So our cuddly toy moose here actually acted as a handy attenuator. Finally, things seem to be working. Let's leave site with a big smile and get back on the ferry. Is this worthwhile, though? Well, the point of 5G kind of is Internet of Things, like really pervasive connectivity. 4G delivered the sort of mobile video streaming that we want for fixed broadband at home. So this project sort of kind of sits between the two because maybe there'll be some agricultural, rural reasons for 5G. But why bother? The core, either if it's hosted or it's self-operated, isn't cheap. You've got stuff to look after. And when you actually look at all of the other operational costs, it's actually probably cheaper just to do 5 gigahertz fixed wireless. There are some benefits. You might be able to do some revenue share for like neutral hosting, partnering with one of the incumbent wireless mobile providers. But generally, if you're just providing internet, it didn't seem worthwhile. So this was a short-term project. And what we actually found during that short-term project is, even though you've brought faster internet to an island, no one's streaming, no one's got a Netflix subscription. The killer app, as far as people were concerned, was being able to make video calls. Because in the darkness of winter, when the weather's terrible, that's what people want to do. They want to keep in touch with people. So what do we do? What's the future for this kind of a project? Well, fibre. How are we going to do fibre? In the UK, there were a whole raft of schemes to try and get providers other than the incumbent to build fibre. And one of these identified that there were about 11,000 premises with a unique property reference number across the islands of Shetland and Orkney that would get some thousands for each premise installed. So let's go back to Papa Westray. It's about 7 kilometres long, 1 kilometre wide. You need a ferry or a plane to get there. The electricity comes from off-island. The water is on the island. They run their own utility company on the island. But there are also many archaeological sites. If you're going to dig fibre here, it's not going to be long before you hit some Neolithic structure and you're now calling Time Team to come and dig up the earth, and your fibre build is on hold. The water is on the island, though. So they took the option of fibre-in-pipe. Talk to the utility company, find a pipe gland that you can actually put fibre into while it's got water in. And so long as the fibre is of a certain grade, it's not going to leach anything out of its plastics. You can get muddy, dig up, find all of the water pipes, drill your hole into it, put the gland around, feed the fibre into that, and now repressurize the water. And the water is going to push your fibre down until it goes pop out the other end. We're doing fibre to the toilet. Thank you for that one, Pascal. So having done that, there are now only 10,931 premises left to solve. And the incumbent operator still hasn't pitched to actually try and solve this problem. So now what? Well, this time last year, I was invited back as part of a sort of blue sky thing, a kind of blue sky project. How can we tackle this? And it was a consortium with ourselves doing the relevant herding of cuddly toy moose. And they basically asked, when are you coming? We want to talk about this. So back I go to the Highlands, to John O'Groats, get on a ferry near there. And if you know, you know. I was very, very glad to be put up in this Airbnb with a view towards the distillery. The walk into town was exactly the same as I remember. Here's a nice calm day where everything is blowing. Get to the office and I'm greeted by a map. And this map shows green is what the incumbent operator is going to deliver, or what has already been delivered by CloudNet. Red is in scope for potentially these vouchers or some other sort of funding source to actually provide more than like VDSL copper technology. The problem statement I was given was, there's very little budget at this stage to find out, is this commercially viable? We just do not know how much fibre we're going to need to dig and how much it's going to cost. We need a rough cost so that we can actually go back to Scottish Government and funders and say, we need roughly this much to actually now do a properly scoped project and then get a more accurate costing. So the approach we took was to get a KMZ of all of the roads on the islands, get a KMZ of all of the properties that are going to be in scope, find the nearest point on each road to the premise. That's going to be a fibre link connecting the premise to the spine. Now calculate the spanning tree of all of those points on the roads, and then multiply by a fudge factor, because fibres are not like birds. And this fudge factor, if you speak to the logistics industry, you can actually get quite good figures for this. It's based on where you're operating. So the logistics industry, if they need to get from A to B, they'll look at the crow flies distance, look at the markets, and then go maybe 1.3 times that distance, because this is rural Africa and the road networks are not dense. Or maybe it's 1.1 times as the crow flies distance, because this is a well-developed part of Europe. So we used a figure in between those two ranges. Some national telcos use 1.6 times because they're assuming the absolute worst. You're going to have to go up, and you're going to have to go across, and then there's going to be some mess as well. So yeah, add a bit more. But we used about 1.3 times. So running our algorithms in some GIS software, we end up with something that looks a bit like this. It's not perfect, right? But you can kind of see if you add maybe 30% onto this, we're getting pretty close, yeah? Now, some areas, when you run this, it's like, oh, okay, this is going to be quite good. We've got that main road with loads of fibre going down as a spine. We've got some stuff coming off. This is high density. This is going to be like really easy to do. And then you go there and realize, actually, this is going to be hell. And that 150 a metre or however much you were costing is not going to even come close to the labour cost. Additionally, when you've got separate towns and villages separated by some distance, the algorithm's not perfect, but it gives us a decent estimate to at least start saying how much do we need to approach government and funding for. So here is what the map looked like for the whole of the set of premises that are in scope. And it roughly looks like a roadmap of these islands. So then I was asked, could you do this for Shetland as well, which now brings 11,000 premises in scope. And what we found was, we're going to need to dig about 500 kilometres of fibre in Orkney, and much of the 550 kilometres on Shetland that would be part of the spine down the roads, most of that exists. And then to connect the premises is going to be potentially a greater cost, because you're going to be digging through people's premises. It's going to be small call-outs. But mashing all of these figures together, it ends up being about 3,500 francs per premise to build this network. The Scottish government was expecting it to be about 3,000. So we weren't far off, but it's a little harder than the government were expecting. And they were hoping to be able to part fund this project, but we're really looking to outside investors to find most of the capital long term. So having done that, I then encountered the first time when the weather got me. I couldn't get home for 3 days because all of the sailings were cancelled because the weather was terrible. Eventually, I did manage to actually find a ferry, but there was like one car left available to get on this. So after an extra weekend and a few days in Orkney, I was finally able to head home. Then what? Well, then there was a layer 9 issue. The UK held a general election, and for many months before that, everyone was expecting a general election and a huge swing in the demographics of the parties. So basically everything stopped. Government stopped talking to anyone. Money, future plans? No. No, we need to keep our jobs. We need to get elected. So unfortunately, we're at the stage now where finally, after this election in July, we're now waiting for the new Labour Scottish government to actually start re-engaging with the infrastructure pledges that they've made. And hopefully this project will then start up again. For now, unfortunately, we're on pause. If you want to know more about some of these projects that we've done, there's a talk where we talk more about the sort of POPs and the travel that we did. There's a UKNOF talk where I talk about how we tried to bring this provider more into the realms of automation without actually building them a fully automated network. Greg from the CloudNet provider has a talk about the fibre-in-pipe deployment. And we also together gave a talk at the Next Generation Access SIG at GEANT. Here's the team, here's who was involved. You've got Trevor and Greg up that tower. You can't see Nikki and the rest of the team from CloudNet, and then some of the helpers that on the islands brought together some of this project. And that's the end of my talk. All that was left was the rather long drive back to where I live, south of Lac Léman. Thank you very much.
Do we have any questions? This was a really interesting talk. Thank you. I see one here. Yes. We just have time for a couple.
Yeah, my name is Bartek from Swisscom. How did you tackle the time synchronization for 5G, or that was not a problem? GPS, local GPS on the mast.
So if I scroll back to where you can see one of those CIPRI cards, where are we? Somewhere here. Yeah, back a couple more is a better picture. Here we go. So that network card that looks as though it's a quad SFP Plus also has a little coax connector next to it. GPS, little antenna outside done, local GPS. One for each area, yeah. Any others? No? Thank you.
No, we finished time actually. So thank you very much. That was really interesting.